Hello guys, welcome to the Let's Crack JEE English. So on this channel we are discussing everything in great detail, and so on this channel we are discussing this is a very good platform where you can clear your doubts. So Let's Crack JEE English. Follow the channel. Myself Rajeev Ranjan. I have done BTech from IIT Kanpur, more than 7 years of experience from in the JEE syllabus, JEE teaching. Alright, Unacademy, the largest learning platform, daily live classes, live test quizzes, structured courses, and unlimited access you get on Unacademy. With one subscription, you can get access to all the teachers teaching for Unacademy and JEE on Unacademy Plus. Live test quizzes will keep your preparation on track. Structured courses, everything will according to be the syllabus. Alright, Unacademy learning app, download the app. Use my code Rajeev RAJEEB for getting 10% discount over and above the 75% discount which you are already getting. 1350 rupees per month for quality education. This is the best deal which you are getting from an academy, so you should really think about it. Alright, so today's topic is friction. Today's topic is what? Friction. Alright. So today's topic is friction. So basically, what is friction? Friction has electromagnetic or electrostatic origin. Electromagnetic friction has electromagnetic origin. So friction has electromagnetic origin. All right. So whenever two surfaces get very close to each other, these two surfaces are like this. And then these two surfaces bump with each other. So this valley bumps with the peak. So this is the peak, and that's the valley. So the peak bumps with the valley. All right. And thus the origin of friction. And thus the origin of friction. So this is the origin of friction. The roughness, the ruggedness of the surface. The ruggedness of the surface leads to friction. The ruggedness of the surface leads to what? Friction. Alright. So what is the, how do we quantify friction? How do we quantify friction? So we'll see that. Before that, we'll draw some graph of friction. So the graph of friction is like this. So it is kept on this, and what do you do here? F. So F is the force, external force. F is the external force. So if you start applying external force on this, the friction also value increases. Initially, when there is F is 0, when there is no external force, the friction value is 0. The friction value is 0. Alright. So finally, so friction value will increase. Then suddenly the friction value will decrease, and this will go like this. So this is called the maximum value of static friction. Maximum value of static friction, and this is your this value is your kinetic friction. This value is your kinetic friction. Kinetic friction. All right. So so this is your F external, and this is your friction value. So as you increase your F external, the friction increases, then it decreases suddenly, and this is your F. Then your force increases. If increase in force does not affect the value of friction, the friction has remained constant. Friction is basically what? Constant. After the maximum value of static friction. Alright. So this is the curve. This is the curve. So a body of mass 400 grams slides on a rough horizontal surface. So let's solve this problem. 400 grams slides on a rough horizontal surface. Slides on a rough horizontal surface. So what is this? 0.4 kg. So this is 0.4. 0.4 kg. Alright. When slides on a rough horizontal surface, the friction force is 3 Newton. The angle made by the contact force on the body along. So if the friction force is 3 Newton, so this is 3 Newton friction, and this is your normal is equal to mg. So 0.4 into 10, so that will be a 4 Newton. Alright, so what is the angle between the contact force and the with the vertical? So this is the contact force net, that will be a 5. Contact force with the horizontal or with the vertical. So vertical with the vertical, it will be tan theta is equal to 3 by 4. Tan theta is equal to 3 by 4. Alright. Tan theta is equal to 3 by 4. So that is the thing. The magnitude of the contact force. So what is the magnitude of contact force? So that will be 3 square plus 4 square. So that's 9 plus 16. 25. So that will be a 5 Newton. That will be a 5 Newton. Alright. So that's 4 mg and this is 3. So this is a 5 Newton. So that's the thing. That's the thing. This is how you. So this is how you understand that what is the contact force. What is the contact force? What is the contact force? So contact force is basically the resultant of friction as well as normal. The resultant of friction as well as normal. So contact force is the resultant of friction as well as normal. So this is friction, that's normal. So this is the contact force. Alright. Now a block slides down an inclined angle 30 degree. So let's quantify the friction. So how to quantify friction is directly proportional to normal. Friction is directly proportional to normal. So friction is equal to mu into n. Alright, friction is equal to mu into n. Here mu is coefficient of friction. Here mu is coefficient of friction. Alright, mu is coefficient of friction. So basically static friction, mu s is the coefficient of static friction. Coefficient of static friction, and mu k coefficient of kinetic friction. Coefficient of kinetic friction. So F is equal to mu s into n and F is equal to mu k into n. Alright, so n is the normal here, normal to the plane. N is the normal here. So let's solve this problem. A block slides down an incline of an angle 30° with acceleration g by 4. Find the kinetic coefficient of kinetic friction. So the block is sliding down. The block is sliding down 30° with acceleration how much? G by 4. Now you know that downward it is mg cos 30, mg sin 30, and upward it is friction. So basically mg sin 30 minus of friction is equal to what? So that will be your m into g by 4. And here it is sliding. So it will be a kinetic friction, mg sin 30 minus, so there will be a kinetic friction. So mu k into mg cos 30. That is mg by 4, right? Sin 30 is mg by 2 and minus mu k into mg into cos 30 how much? Root 3 by 2. So this is how much? Mu k into mg root 3 by 2 is equal to, this will be minus mg by 2. So plus mg by 2 and minus mg by 4. So mg by 4. So from here mg, from here to mu k will be 1 by 2 root 3. So that's the value. mg 1 by 2 root 3. So mu k will be 1 by 2 root. So that is the answer. Alright, so this is how you solve this problem. The force of kinetic friction will be mu k into n. The force of kinetic friction will be mu k into n. Mu k into n. So that is the thing. This is how you kind of solve the problem. Let's solve another problem. So let's see this. A heavy box of mass 20 kg is pulled on a horizontal surface by applying horizontal force. Now, if the coefficient of kinetic friction between the box and the horizontal surface is 0.25. So here mu k will be how much? 0.25. A heavy box of mass 20 kg. How much? Mass 20 kg is pulled on a horizontal surface by applying a horizontal force. If the coefficient of kinetic friction between the box and the horizontal surface is 0.25, find the force of friction exerted by horizontal surface. Alright, heavy box is pulled horizontal by applying horizontal force. So basically, find the force of friction. This is the kinetic sliding friction. This is the sliding friction. Alright, that's the sliding friction. So sliding friction value is mu k into mg. Simply, what is mu k? Mu k is 0.25. 0.25 into mg. What is mg? 200. So how much it will be? It will be a 50 Newton. So 50 Newton it is the force on it. 50 Newton is the force on it. Find the force of it exerted by the horizontal surface. So that's the thing. Let's solve another problem. A boy 30 kg sitting on his horse whips the horse. speeds up at an average acceleration of n. If the boy does not slide back, what is the force of friction? So when you'll see from the ground frame, if this is the horse, so nice horse, and the boy is sitting here. So from the ground frame, it is accelerating. So friction must be accelerating. There can be only the friction can be the external force. So F is equal to m into a. So if the boy slides back during the, if the boy does not slide back, what is the friction force exerted by the horse? So basically mass is 30 into 2, so 60 Newton will be the friction force. 60 Newton will be the friction force in the forward direction. Now, if the boy slides during the acceleration, if the boy slides during the acceleration, what can be said about the coefficient of friction? So 60 Newton must be the maximum friction, static friction. I told you this is the maximum friction that can be applied by the surface. So this is the 60 Newton. Alright, that this 60 should be equal to mu s into n. So there is no sliding actually. With respect to the horse, it is at rest. So this is there is no sliding. So there will be a static friction. So what is the mu s? So mu s will be 60 by n. What is n? N is 300. Alright, because if you draw the, so that will n and this is mg. So n is what? N is equal to 300. N is 300. Alright, so this is 300. And mu s will be basically 60 by 300. So that is 1 by 5. So mu s value is 0.2. Mu s value is 0.2. Alright, so we can say about the static friction, coefficient of static friction, that its value is point, that's value is 0.2. So let's summarize what all we have done today. Let's summarize what we have done today. So basically what we did today, we learned that electromagnetic force is responsible for friction. Electrostatic force, electromagnetic force is responsible for friction. Alright. Second thing we learned that friction depends upon the normal to a surface. And third thing we learned the quantifying of friction. So what is quantifying of friction? Friction is mu into n. Mu is coefficient of static friction. N is the normal. Alright. And fourth, we learned that there is a maximum value of static friction. So static friction when the sliding is not there. Then there is a friction which is called sliding friction. It appears when the sliding starts happening. So this is sliding friction. This is your sliding friction. Alright. So this is a lesser than the maximum value of static friction. Lesser than the max value of static friction. Max value of static friction. Alright, so these are the things. These are the things that we did today. Anusmita Sahu. Hi Anusmita Sahu. How are you? So these are the things that we did today. Static friction. So and the graph that we did. So if we apply an external force on this object and we measure up the friction. So friction will first increase, then it will suddenly decrease. So this is the max value of static friction. Max value of static friction. And this is the kinetic friction. The constant value of friction is kinetic friction, or you can say sliding friction. Alright, so sliding friction. So these are the things that we did today. So I think you should, this was the theory, and with some good examples. I think this suffices today's session, and more such type of session will come, and problem solving session will be taken. Alright, so myself Rajeev Ranjan, I have done BTech from IIT Kanpur, more than 7 years of experience in physics pedagogy. Alright, so you can subscribe to Unacademy Plus platform. It's a very good opportunity for a nice and solid and very comprehensive preparation. Alright, so Rajeev, RJWV for 10% discount. Alright.